Today I am going to present a topic on destination sequence distance vector routing protocol on mobile ad hoc networks. So the outline of this lecture is introduction, classification of routing protocols, reactive protocol, hybrid protocol, proactive protocol, and the example of DSDV protocol. So first of all, we want to discuss about what is mobile ad hoc networks. So mobile ad hoc networks is mostly host movement frequently. Here the nodes are dynamic in nature, whereas in cellular network the nodes are fixed one. In mobile ad hoc the nodes are dynamic. The mobility of the nodes will be frequently occur here. The topology change frequently. Due to the mobility nature of the node, the topology of a particular network will be frequently changed. For example, at the initial state, the node A and B is in a topology. During a certain interval of time, the mobility of node takes place, so the topology changes. So here no cellular infrastructure, multi-hop wireless links are there. Data must be routed via intermediate nodes. The data or data communication taken place between the source and destination node via intermediate nodes. The classification of routing protocols. The routing protocol of ad hoc networks can be classified into various types. There are groups under the routing information updation mechanism as well as temporal information for routing. So in routing information updation mechanism, we further classified into three types, that is proactive protocol, reactive and hybrid, whereas in temporal information for routing, we taken the account of past information, past history and their predictions. So under each and every protocol, we have different types of classification of protocols. So route information updations. So in route information updation mechanism, so this particular technique will be classified under three classification, that is proactive protocol, reactive protocol and hybrid protocols. In proactive protocol, it is a traditional distributed shortest path protocol. It maintains routes between every host pair at all times. In mobile ad hoc network, each and every node enter into a network can maintain a route table which stored information about a source, destinations and sequence numbers. So these route updation will be taken place frequently based on their periodic updations. So at a regular interval of times, due to the changes of the nodes, the route informations will be updated. High routing overhead occur. Example for this proactive protocol is DSDV, which is termed as destination sequence distance vector. Next one is reactive protocol. It determines the route if and when needed. On demand, the route table will be exist. The information about a particular source and destinations and intermediate node will be taken account. Source initiated route discovery technique will be followed here. Example for reactive protocol is DSR, dynamic source routing. Next one is hybrid protocol. So hybrid protocol is nothing but a combination of proactive and reactive protocol, which is also termed as adaptive protocol. Example for hybrid protocol is ZRP, that is zone routing protocols. So today we are going to discuss about the destination sequence distance vector routing protocol. So this protocol will based upon the modification of Bellman-Ford algorithm. So in this algorithm, it has some properties and characteristics. This algorithm maintains the two important factors, that is the shortest path to the destination and well as the first node of this particular shortest path. The both parameters will be maintained here. Then this protocol will be categorized by the following, that is first one is the routes to the destination are readily available at each node in the routing table. Every node in the particular network will maintain a routing table. The particular routing table updation will be taken place at a regular interval of time. This routing table or exchange between the neighbors at regular intervals. So the route information updation can be propagated to the neighbor node at the regular basis of time. It also exchange when significant changes in local topology are observed by the node. Any node mobility will be taken, then what happened, the particular topology will be changes, then the particular information is also updated to the neighbor nodes in the particular topology, that is local topology. So route table updations. Route table updation can be followed by two methodologies, that is incremental update is a first one. Here that it takes place when a node does not observe significant changes in the local topology. Major changes that does not occur in the particular topology, then incremental update will be suggested. Whereas any changes are observed in the network topology, we can go for full dumps. So here the route table will have a following parameters, that is the node, destination of the particular node, that is source node, destination node of the particular node. What is the intermediate node? Here the next to hope is nothing but the intermediate node between the source and destination node, then the distance between the node, and finally the sequence number. The sequence number will be randomly generated. So, working principle of destination sequence distance vector protocol. Here the node broadcasts their routing tables to intermediate neighbor nodes with the sequence number. Any node in a particular network will going to communicate with each other. What happened? The source node will propagate the informations to the neighbor nodes. The neighbor node should find out the destination ID. So, based upon the destination ID, it transmits the data to the intermediate node. If the destination ID is equal to the same source ID, then the data will be received to the particular node. So, every time any broadcasting occurs, the sequence number is also updated along with the distance of the nodes. So, the route table updation will be taken place at the regular interval of time. So, here we can discuss this with an example. So, we are going to take a network which consists of 3 nodes. So, each and every node has the distance of 1 with the each edges respectively. So, this is the example. So, in a network we are going to take in 3 nodes which is called as node X, Y and Z. So, there will be the edges between X and Y and Z with the cost of 1. So, first step in DSDV is you want to draw a separate table, that is route table for all the nodes which is X, Y and Z along with the distance and the sequence number. So, here I am going to take draft the X table. So, in this network we are taking the X node. So this is the routing table. So, we have the parameters such as source ID, destination ID, next hope, cost and sequence number. So, the source is X. So, the first the path is X to X. So, X is a self looped node. So, destination is also X. So, no next hope is there. So, cost also 0. So, randomly the sequence number will also generated as 100 to X. Next step we want to check the X node with Y. So, X to Y, there exists a edge of the cost 1. So, the cost is 1. What is the next hope? Next hope is there is no intermediate node between X and Y. So, the next hope here is Y node. The destination node is also taken here as a next hope. So, X is a source, destination Y and next Y, next hope is Y and cost is 1. Then sequence number. Then we want to consider X to Z. X to Z. So, we have for X to Z, we have the traversal between X to Y and Y to Z. So, the intermediate node is Y. The intermediate node is Y. Intermediate X for X. The intermediate, so X to Y, Y to Z, the intermediate node is Y here. Then the cost of this particular traversal will be 1 plus 1, 2 and the next hope is Y and destination node is Z. Next we want to consider the Y node. As well as we take the Y node, we want to traversal with X, Y and also Z. Then source Y to X. So, Y to X, the next hope is X, since X is a destination and there exists a cost 1. Similarly, we want to take Y to Y. Y to Y is a self node. So, the next hope and destination node is same. There is no cost 0. Then we want to take Y to Z. So, Y to Z, the next hope is Y and the cost is 1. Similarly, we need to construct Z node. So while taking Z node, we want to travels with the neighbor nodes X as well as Y. So Z to X, we want to travel from the node Z to X through Y. So Y is the intermediate node, so Y is said to be a next hop. The cost will be Z to Y 1 and Y to X 1, then 1 plus 1, the cost will be 2. As well as we want to check with Z to Y. Z to Y, the Y is the next node and Y is the destination, the cost is 1. So Z to Z is self node, so there is no cost, next hop and destination node will be the same. So this is the method, this is the way to construct a route table for each and every node present in the network. So here we taken only 3 nodes. When we are taken into a large amount of nodes, then each and every node should maintain the route table as we discussed in the previous example. For example, we take case 1. If Y node wants to broadcast a message via routing table, then updating the routing tables of all the nodes in the network with the will be taken place. So what happened? Where the updation will be happened? So for X via Y node will be taken into the account. For Y to Y will be taken into account, and for Z to Y. So the nodes which are neighbor to Y node will be taken into the account over here. So this is the reconfiguration of paths. So why we going for reconfiguration of path? So the nature of mobile ad hoc network is node mobility. So due to the node mobility, what happened? The topology will be changed frequently. So this is the problem for path breaking or link failure in the networks. So during such situation, what happened? We need to reconfiguration the path during the path break. So there is some guidelines to follow while reconfiguration the path in the network. So what happened? The first step is the end node of the broken link sends a table update message. So the node which break previous node will send the updation message to the neighbor node. The message will contain broken link weight which is assigned to infinitive and sequence number greater than the stored sequence number of the destination. So in previous example, we see the network which consists of the 3 nodes X, Y and Z. Suppose the node due to mobility of node while changes its distance, what happened? The topology will be changed and there will be a path between X and Z only. So what happened? The X node, the Y node should update the route message to the X node with the following parameter. The particular weight of the Y node should be indicated as infinitive. Then we want to indicate a sequence number which is greater than the stored sequence number, and next one is each node resend this message to its neighbors to propagate the broken link in the network. So the particular broken link should be intimated to all the nodes present in the particular network. It can be happen by broadcasting this updating routing table to the neighbor node. So here even sequence number is generated by the end node, whereas other nodes can generate the odd sequence number. So important note here is a single link break leads to the propagation of route table updates throughout the whole network. If a single node is break the particular path, what happened? The particular information should be broadcast to each and every node present in the network. So this is the one important drawback in DSDV. So advantages and disadvantages. So advantages is DSDV was one of the earlier algorithms available. It is quite suitable for creating a ad hoc networks with smaller number of nodes. So it is very suitable for nodes which have network which have a smaller amount of nodes. So no formal specification of this algorithm is present and no commercial implementation of this algorithm. The main advantage of this method is it is a loop free path. So disadvantage, So here what happened in DSDV, at regular interval of time basis, the root table should update its routing table informations and should propagate the informations to the neighbor node. So at regular interval of time, what happened, the node will be refreshed continuously. So this occurs the battery power and bandwidth of the node. So even the particular node is ideal, what happened, the refreshment will be taken place and updation of information also taken place. So this is a very important drawback here. So whenever the topology of network changes, a new sequence number is necessary before the network reconfigures. Thus, DSDV is not suitable for highly dynamic networks. Thank you.